For this very much initiative of myself and Lawrence and a few others within Faculty of Medicine and Health to put this thing together for all of you. But before we start, I would like to acknowledge that we are meeting on the land of Bijigal people, and those are the first innovators who've been living on this land. And I would like to pay my respect to the eldest, past and present. So today it's a big topic for us, and we are all at Michael Crouch Innovation Center, which is operated by NSW founders. For those of you who don't know us, we are university's vehicle to do anything entrepreneurship. So we help staff, student, alumni, academics, industry professionals to go from I might have an idea to moving and scaling globally. So we operate on the large numbers, and we do have life sciences, health, and biotech as one of our core industry verticals. We also offer coaching sessions and other support programs to anyone on campus who wish to be upskilled. And today we have a very special session, so I will be here just to kick off a conversation. My name is Dina Titkova. I'm one of the managers within NSW Founders. I oversee our startup portfolio, so working with those companies that have already incorporated and need funding to grow. And I'm very much pleased to have Swan Genomics global team joining us here today to unpack what does it take to go from an invention or innovation to something that has impact in the real world environment. What are some key success criteria are there, and what all of us can learn on how to advance your innovations to market. So before I start, I just would like to understand who is in the room, so we kind of tailor our talk as well. I assume Faculty of Medicine and Health, academics? If you can just raise your hands just to understand. Okay, science? Engineering? Nope, and I can see some investment representation here, which is great. Good, welcome. So before to start us with, on this panel we have, I tried to count how many decades of industry experience, and I think it will be hitting towards 200 enjoined aggregated value. So Brooke, if we can just start with you. When I try just to learn more about everything that you've done, I realized I won't have enough time even to go through all your accolades. Can you just highlight maybe 3 things for the audience you're most proud of, what you achieved when it comes to genomics and making healthcare better?
Okay, my name is Brock Siegel. I've been in the industry before it was an industry.
Yep.
I'd say maybe 30, 40 years. I come at it from the technical side, but my family used to own 37 retail women's fashion shoes stores. So the notion of dealing with customers, money, inventory, product, material, is deeply ingrained in me. So I combine that with a technical background.
Fantastic.
So I'll put that as one item. A second item is my blood went into the first human genome that was sequenced. There were 6 of us. One of us got 97% of the amount. That's Craig Venter.
Wow.
The others are crammed in that 3% that makes Craig look like he has various diseases. So that's for my blood. And I think the third is that I've not only put my life into this in time and my life into this in blood, but I have donated my firstborn to the field because he is also using all the tools that I've helped develop to further the progress of biological sciences in food and medicine. So you've got my life, my blood, and my son.
I clearly did not got this when I Googled, right? So I got a lot of different accolades, like PhDs and building companies and making those companies acquired and driving genomic and stuff. But you heard what's the most important. We'll go to this. Bill, what about you? 3 things that you're most proud when it comes to...
Well, it's humbling to sit next to his genomic god, who gives his son. Okay. I wear a couple of different hats. My name is Bill Hune. I am on faculty at UCSF, University of California, San Francisco. I've been there since '85 in various departments. I'm currently in lab medicine. The other hat I get to wear is as an investor. So I'm part of a venture fund called Genoa Ventures. I've co-founded 12 companies, but I've never left the university because it's warm and fuzzy and cozy. And like I said, I got library privileges. So if you would like to give me money, I will give you my UCSF email. If you want me to give you money, then I have Genoa Ventures email. So we can work it sort of that way. The companies and the technologies that I've been part of have been mostly in the field of cytometry. So I started there. If I get to tell my butterfly story, where you have the blue butterflies that flap their wings in the blue mountains that create tsunamis in wherever across the world, I sorted chromosomes 11 through 15. Those are about the same size back in the late 80s. And so without sorting those chromosomes, you wouldn't have the chromosome libraries. It would have only been the partial genome project so that was my very small contribution into the whole genome project. I came to Swan through Brock. We wanted to, he said, there's Lawrence of Australia. I said, this is a great name for a company, Lawrence of Australia. I don't think Lawrence liked the name for the company, so we found a better name. Thanks to Marasa, we now have a logo. But it was one of those epiphany technologies where I heard it and I go, why hasn't anybody else thought of this? We can get into what that detail is, but the combination of a nano antenna with plasmonics tied to a cool technology like origami was just like one of those things. And I said, I've got to be part of this. So that's why I'm here.
And we'll unpack more about Swan Genomics as well. Marasa, what about you?
Hi, my name's Marasa, and I have been part of Swan for about 2 months now, and I'm helping lead product and business strategy. And my background, I have a PhD in human genetics, molecular biology, and have been a serial startup person. This is my 6th startup, and I guess one of my greatest achievements is developing one of the first non-invasive prenatal tests that was brought to the market, being very early, whiteboarding, oligo designs, content development, and then seeing the very first patient sample come through the door to going to 1,000 samples per day. So that was a phenomenal achievement, and now this is something that's standard of care now, doing these cell-free DNA blood draws. I've been part of 2 major acquisitions by Roche Sequencing and Pacific Biosciences. I have also developed short-read sequencers. I was part of Omniome, which was a short-read platform that developed a highly accurate short-read sequencing platform. I was there for a number of years before we were acquired by Pacific Biosciences and has launched the ONSO sequencing platform. That was the platform that I helped develop. And yeah, I'm very excited to be here and happy to take questions.
Thank you. Yes. David? Yes. Just a bit about you and what would you like to share with the audience when it comes to genomics, innovation, your role, what you're proud about?
Good morning, or maybe it's still morning. Okay. I'm David Hsu. My training was probably similar to many of yours. I trained in biochemistry, molecular biology. Entered the world of functional genomics late in my postdoctoral career, which gave me a taste of that. As we all did, had to make a decision, joining industry or staying in academia, and made that choice to jump over. I spent about a decade in drug discovery, actually, mostly on platform technology development, which is where a lot of the innovation happens. I had the opportunity to move into the genomics field because these guys had kind of paved the way, leading the door, opening the door to the next generation, and I spent over a decade at Pacific Biosciences being pretty intimately involved in developing many aspects of the long-read technology and showing how it can unlock kind of a deeper level of understanding of how our genomes affect our biology. And then when I learned about this team and this technology, it was a very compelling story, and I joined. Just a little after. Well, actually, I think we joined the same day, probably. Yeah.
Fantastic. And last but not least, we have Lawrence, who is the outlier on the panel, right, Lawrence? So nothing to do with genomics, I reckon, in your academic training. Lawrence won't remember this, but we met in 2019 when I was given a tour at Single Molecule Science Center, and someone pointed at Lawrence and said, "You have to watch this guy, he will do big things." So 5 years in, we have him on stage, so I may go back to the person who pointed at Lawrence and maybe ask me to point a few other ways as well. But Lawrence, what about you, and why you are with this genomics crew while genomics have not been your training?
That's a good question. I definitely am the outlier with zero industry experience and zero experience in genomics. Marassa still gives me genomics one-on-one tutorials on different aspects of genomics. I came up through academia, and on reflection, my focus on academia was the people. It was about nurturing a way that the people within the lab knew how to think, knew how to be rigorous, and knew how to be creative. Mm-hmm. And so we were always doing stuff that was on the edge. We were never trying to chase citations by going to the most crowded field. And I think, all of our publications are ones that we're proud of because people hadn't done that before. And it was just not through design, just by nurturing creativity. There was about 2019. About then, yeah. Maybe a bit before that. And I said, well, hang on, we are now one of the only labs in the world who have all the different components who could probably build this thing. Mm-hmm. And then I met with Min. Min was in China. We put an advertisement for a PhD ad, and said, "Hey Min, what do you think about building a DNA sequencer?" And I think her response was like, "Sounds cool," and it wasn't an easy road, but over time, we slowly started to build the components together. We had proof that it would, in principle, work. I had to knock down the door of Brock Siegel, who didn't want to know who I was.
Yeah.
And then once we really knew that it could work, it was very obvious we couldn't continue the journey in academia. I think academia, in terms of the budget and scale, focused on conceptual innovations, but to really get this to market or to have an impact globally, we had to think in a different scale. And that's why I'm sitting here now with these people who've done it before.
Was the best brains in industry. So now when we met people, let's meet the company. So Lawrence, in the spirit of startups, so what is the pitch for Swan Genomics? Why shall we get excited? What will it do in 10 years to my life?
I would say at the moment genomics is not really routine. It's still something which you have access to in fairly rarefied circumstances, and the interpretation of the data is also fairly rarefied. There's many reasons why that is, including cultural workflow, policy, education. But one of the big bottlenecks is technology. There isn't a single instrument that does everything. There is a dominant technology which Brock was pivotal in bringing into the world. It's dominated by Illumina, which is short-read sequencing. And that is delivering what's cheap now in terms of genomics. The cost isn't the barrier. It's delivering throughput, but it's delivering it in fragments of around 300 bases, whereas your human genome is around 3 billion bases. So you never actually quite capture all the information. And then you have the technology that Dave developed in Pacific Biosciences, which is long read. And that does, in principle, capture all the technology, but it's very expensive and doesn't have the throughput. I think what Swan can deliver is a single instrument that can then capture all of genomics. right? A single instrument where all the development's focused on one system. How that can impact the world is that it should be the technology piece that enables routine genomics, as opposed to genomics being something for very specific circumstances.
So same question for all of you. You joined Swan for some reason. What is this one thing that made you so excited that you just, I'll be traveling to this, faraway island of Australia and actually we'll do this?
Well, you're putting me on the spot here. And of course, I should gravitate toward the exciting technology that is absolutely a breakthrough that I've been looking for 2 decades. What Lawrence has discovered is just phenomenal. And I think it can be applied in multiple different ways. And depending on how we choose to use it, you can get more accuracy, more throughput, lower cost, a variety. In fact, there is not a dimension to genomics that we have looked at that cannot make use of this. It's so pivotal and functional. Okay, that's all interesting, good, terrific. I mentioned I started before biotech and genomics those words didn't exist. They really did not exist. And I worked with a company called Applied Biosystems that wanted to automate biology, biological studies. And from that effort, we came out with the world's first automated DNA sequencer. Terrific. That was a smash hit, a real breakthrough.
What year was it? What year was it?
Well, the first box shipped in 1987, although it didn't really ship. It was the second box we built because the first box, everybody was out there all excited. It fell off the truck. But we had a second one, so we could ship that. After Applied Biosystems gained about 98% of the market share, we'd sequenced the human genome.
Can we just pause here? 98%.
98.
Yeah.
Everybody throughout the world used our technology, our boxes, our equipment, our reagents, everything. Genomics was based on applied biology. I looked over and saw this twice failed startup out of Cambridge, England. I said, oh my God, that technology combined with computational capabilities is going to obsolete what we do fast. Well, I left the comfort warmth, went into what was called Solexa, and very shortly thereafter, we launched our product, 2006, and it took over the world of genomics. It was a winner-take-all instant, $0 to $100 million in the first year. 0. There was no short ramp up. Okay, so that's 2 technologies. What am I really doing here?
Yes.
Lawrence has got the third.
Yes.
And that third's probably the last we're going to need. You're going to be so close to perfection that there's just not enough going after. I mean, you'll probably be 95% of the... I mean, you can squeeze out a little bit more. But that'll give me a trifecta. And I don't think my kids are going to be able... My firstborn, whose work was just cited in the Nobel Prize given this year.
Wow.
He's going to Sweden.
Oh.
As one of the members of the contingency. But he won't have a trifecta. So that's why I'm here.
Can we just pause here? It's such a phenomenal numbers and story that's, I don't know, what about you? For me, it's hard to process. Like 95% of the market, changing the world and stuff. But this is what we all believe is happening through a Swan Genomics team that is actually UNSW spin out. And we'll get more from Lawrence on how he got where he is. But I'll just want to finish the round and really get this, like Bill from you, Swan Genomics for you, what is it? What do you see as the future?
Yeah, it's kind of fun that we're all here, and we can all look back to this time and say we knew Lawrence when, you know. So I've had a lucky career. So I've been in academia, like I mentioned. I've been party to work with smart people that have developed things like FISH and CGH and quantum dots and T-cell therapies. And so I've seen and have been part of a lot of commercial efforts that spun out of academia. And like I said, I've co-founded 12 companies. Well, I have to say I was a really lazy grant writer, because one of the things I figured out early is I could form strategic partnerships with my academic lab to start to build some of those technologies. So I worked with Beckman Dickinson, I worked with Zeiss, I worked with Danaher, and it was much easier to get monies to validate and build technologies within my lab than sometimes getting a grant from our NIH, our Institute of Health. And so 20 commercial products later, and I see the Swan technology, and I'm going, this may beat all of them. And I've been part of companies like Juno. Brock and I just sold a single-cell genomics company called Fluent. So, this is one of these where you go, okay, this has that potential. That's, again, what I hope we can help realize. It's really ours to mess up, and hopefully we don't do that.
Marasa, like you personally, 2 months in, why? How's it going?
Right, so I think I can boil it down to 3 things. One is the technology, so plasmonics, the concept of a plasmonic nano antenna, being able to really drive signal as sort of infinitely. It's been around for a really long time, and seeing the capability of this sensor and its various applications, not just in sequencing, but other potentials in genomics, or just broadly omics, is one reason. And being able to see sort of firsthand what that data looks like is really exciting. The second part is the people. I've, again, had the fortune of working in a variety of different startups and working with some of the brightest people I've ever met, and sort of you get that gut feeling of like, this is the team that I want to be with. Just meeting everyone, it's just a really good team of people. So that's the second. And then I think the third is startups aren't really for the faint of heart. There's a lot of ups and downs, and so being able to tether yourself to a grander vision of what the company means, rather than just the day-to-day data generation and being able to pull out signal, or like how much of the market are we going to take. It's more about like what is this company going to mean in the 10-year long term? What does this look like 10 years from now, 20 years from now? And what's my contribution going to be to that? And I truly, having been both in the diagnostic space as well as in the development of technology and platforms, I see the value of personalized genomics and where that can lead us, and it's the future. And I really think this one's going to be there. So those are my 3.
Thank you. Yes, David.
So my entry into Swan was, I think, really 2 reasons. In the field of genomics, Lawrence alluded to this, accessibility is an issue, and that's driven by cost, it's driven by the quality of the data and how easily it's analyzed and interpreted. And so this technology promises to really move that bar forward. Maybe more important for me, because at heart I'm a biologist, is new biology. So bless his heart, the genomes that Brock enabled are like 1,000-piece jigsaw puzzle with the most important 100 pieces removed out of it. And as we push and develop better tools and the kind of technology that Swan has a capability of achieving is going to fill in those blanks. And I'm quite confident. I mean, we already have data sets coming out showing that there's new human biology, new animal, plant biology coming out of that understanding. but we need to accelerate it because the way to do it right now is it's slow, or it's rather expensive, or it gives kind of murky results. So there's a real opportunity for medicine and biology.
Thank you so much. So, Lawrence, let's just final kind of series of questions from me, and then I'll pass to all of you because we really wanted this to be a learning opportunity for everyone at UNSW to learn about the trends, how work with industry, how go and combine your academic career with industry engagement and so forth. So please do get your questions ready. But Lawrence, so you identified the potential of your research, and then you decided to take the step, I will be spinning out. Can you please just walk the audience through your journey and what things you're most proud of, which I assume forming this team will be one of?
Yeah, absolutely. Forming the whole team, not just the leadership team, but especially the team that we have in Sydney. The first time we brought this together, it was Min and James and I in an academic lab. And I remember the first time we saw a trace, we were like, okay, now what do we do?
Let's put timeline on this. So was it 2021, 2022? When did you start kind of thinking about spinning out and forming a company?
The idea was, well, it was probably probably when we first started. We knew that if this was to work, we need to go the commercial path if we're going to do anything with it. But there's a timing aspect to that, and I was totally clueless. And I was very lucky to have people like Peter Gunning and John Mattick, and Marcel Dinger, who are in Genomics. And I'll just be chatting with them, saying, "Oh, this is what we're building," and they would say, "Well, you need a patent, you need to do this, you do that." And for me, it was quite foreign because I was very much a curiosity-driven researcher. So I'd say it's slow to sink in. And then I remember distinctly James and Min and I were sitting here and saying, "Okay, well, we're going to try and get some money now. Who's going to run the company?" And we're going, "Well, what do you mean? Why do you need to run the company? We're just going to do some more research." So it was really quite naive. And then as I went on the journey, I remember someone said, "Hey, you should come and chat with these investors." And I said, "Okay, I will chat with these investors." And they had a very strong scientific board who was technical, assessing it, and I just chatted through. And then I walked out and they had an offer straight away. And I was like, wow, this became real very quickly. And I don't know whether that's a good offer or a bad offer. And all I kept telling myself is, I don't know what I'm doing, I better find out. And so there was this, and I still think I am that naive, but I did spend a lot of time trying to make sure that we're rigorous about decisions, trying to make sure that I had reference points, because without reference points, it looks like a lot of money on the table. And it's a lot more money than you'd otherwise get with a research grant. And it took me one meeting to get it, right? So part of you is saying, that's great, let's go for it. That's where having Brock and Bill was pivotal. I don't know how this would have worked at all without having these guys in the room at the beginning. They gave me the reference point. They said, that's a good deal, that's not a good deal, this is what we expect, this is what you shouldn't do. Brock would have a look. I don't know if he knows a look, but he'd have a look, because a lot of these meetings were online, so I'd know, okay, I shouldn't have said that. And they had the humility to, in fact, I got frustrated with them, because I thought, Brock's done this before so many times, and Bill's done this so many times before. Why don't they give me the answer? And I'd ask questions, and they go, "Oh yeah, well that's a project. We've got to figure this out." And I slowly began to realise that if they were advisors, they were co-founders who came in and said, "This is the way it has to be done," I now know that's a red flag. There are certain things that we know. Bill always says we know what not to do, but actually the complex problems remain complex. And the fact that they didn't come and say that we know better was a sense of humility that kind of threaded through this entire interaction. So I think maintaining that sense of humility and that culture within this organisation is the other thing that I'm very proud of.
please do share with the audience, those who have not heard the story yet, how you were knocking on Bill's and Brooke's door, and how did you finally manage to get in front of them? Because I know it took you a few attempts.
Brock tells the story better than me.
Okay, let's go to Brooke.
Oh dear. What I've tried to convey in my prior comments was that the skills, the knowledge, the experience, that's all absolutely essential to have. Not only for knowing what not to do, but at least knowing where to look to find what to do. The essential other ingredient that I've tried to express is passion. Mm-hmm. You have to have visceral passion. If your passion is not associated with it, as Marasa said, you're going to hit mountains that you just can't climb. The only thing that'll drive you through is passion. Mm-hmm. I was passionately looking at coming in for a smooth retirement landing. And a good colleague of mine, a friend of mine, I'd hired him as a CEO in one of my companies, and I had to fire him, but he came over to Australia. I met Lawrence and said, Brock, yeah, I talked to this guy about sequencer. I said, oh, God, not another sequencer. I put 11 of them on the market. I've done enough. And he kept pestering me, and so I said, okay, fine, I'll have a call with him, half hour. What doesn't matter. This is all passion. This is all emotion. Mm-hmm. And about 20 minutes into the call, Lawrence has heard this story so many times, I just looked at him on the Zoom screen and said, I hate you. My life was all set. You're going to make me jump back in. It's not the Holy Grail, exactly, but he had what I had been looking for years. As I said before, a couple decades. He can take all this big equipment that's needed to make detectors and simplify them into a little teeny thing. And that's really essential. And my passion was ignited by that. The skills, knowledge, experience, the technology, how it fits into the big picture, sure. That's all there. It was the passion I felt. And I hated his guts. So I had to talk with him now. Mm-hmm. I was self-motivated time and time again. And maybe every 3-4 months he'd give me a call, and then, oh God, this guy again. What's he got? And he shows me some data. I said, oh my God, this thing's real. That's better data than most startups ever have at the beginning. And it's in Australia, where there's government tax support, the wage arbitrage, the openness, the culture that's here, the lifestyle that's here. It's a good recipe. Well, let's go do this.
That's fantastic.
So I started talking regularly, I think weekly, and then twice weekly. I knew I didn't know enough about it exactly, so I gave the stuff to Bill, and Bill, let's see, how do I politely say it? He got very excited.
Yeah.
Yeah. And as soon as Bill did that, I said, okay, my nose has led me to the right place. So that's how it got started.
I love hearing now the second side of the story as well, because the first side of the story I heard how you kind of gently was emailing, and no one was replying, and then you managed to, can you just share with the audience how you actually got in front of Brooke for the first time?
Joel nearly made me write an application. I had to write something to send to this guy called Brock.
There was no roadblock I could put in front of him that he wouldn't overcome. Damn, I didn't want to do this.
This is a story of perseverance as well. So with this one, I would like to kind of pass it to the audience, because all of you coming from different research groups and in different kind of stages of your journey. And on stage, we basically have people in the world who brought latest genomic sequence and diagnostic tools and platforms to the market that were acquired, that were successful in seeing them come in live. So anyone brave enough to start the series of questions before I go more to generic and unpacking the story, which I can do for many hours, trust me. But I just want to give you an opportunity to ask your questions. Anyone? Just grab a microphone, we're recording.
That on. Thank you so much, everyone. It's been amazing learning your journeys and seeing how impact is different for each of you. This one's for Lawrence. Interesting story, Lawrence. You were on my first RPR panel group for my PhD, which is now done. I'm curious to learn from you, what are some of the skills you learned that you had to rapidly develop when you started making the move from academia into your startup?
Great question.
Well, first of all, congratulations. What skills? Everything, really. It's a totally different perspective in relative to academia. What is the key skill? I really think it's basically just listening and trying to understand and constantly asking yourself, well, what is it that I don't see here? There's just a fundamental difference because when you're trying to show a conceptual advance, sometimes you just need to show that it's possible just once, and then you can write that paper. And sometimes it's not what you had expected, but there's still a story there and you can write that paper. The startup is real. You know, if you don't make the right decision to enable it to work, it can fail. So there had to be this consistent, because many times I would come in, the team will tell you, oh, this is the answer. And it feels so strongly the answer. And I had to resist that. I had to think, okay, I feel strongly about that, but I still need to ask, why is James giving me a funny look when I'm saying that? And I think that was probably the most important, to look for what I don't understand and listen to people and allow yourself to adapt. Yeah. I can't say one specific area, but every area.
Yeah.
I might have a corollary to that. I have an academic lab. And with the academic hat on, you're the PI, you're essentially your own entity. You have to write the grants, to bring in the money, to fund your lab, to create the team, and you operate as a PI. And that academic PI-ness sort of sets a hierarchy where you're supposed to know. You're supposed to be able to put together the proposals, create the collaborations, form the key aspects or driving towards whatever the questions you're trying to answer. When you go off into, and this was my learning, when you develop that core technology that could have commercial potential, you have to switch the mindset of the people that you're working with to challenge you now. They can't tell you what they think you want to hear. They have to tell you what you need to hear, because that's the only way that a startup technology is going to be successful. I don't know if that subtlety just came through, but it's not that I'm going to dictate to you how to look at your data, how to run your experiment as a PI. It's that you're going to tell me these are the things that we have to achieve in order to get to the product, to get to success. And some labs work in both ways, but it definitely is a switch, just to sort of put some nuance on there.
Maybe one small comment in terms of skills that I think directly about. If I were to use a sports analogy, one of the transitions from academic life is in academia, you're on a swim team, you're a tennis player, you're a track and field runner. You kind of carry the ball for yourself. You go into industry and everything will be team-based because most of the challenge you face, there's not one single person in the room who will hold everything necessary to get the answer. And you could see that in our team right now, where we have one person who knows how to do this part of the experiment, one person who knows how to best analyze and interpret it, one person who can do the projection of what we need to be doing 3 weeks from now. It's a highly integrated social effort.
Thank you. Next question. Sangeeta first. And maybe just introduce yourself as well. No, just use the microphone because we're recording.
Okay, so myself Sangeeta, and I am also a genomic researcher. So I didn't want to introduce, I wanted to ask my question, but I didn't ask me. So I did my research, patent, and innovations on next generation DNA synthesis. And Solex, a person, we were working in the same group and selling the technology and in Oxford and Cambridge. There we were working together. I recently moved to Australia, and this is a great technology, I believe, in genomics and sequencing. I really want to know what's the uniqueness of the Swan Genomics. It's a technology, definitely. So compared to the present technologies, what available for the sequencing at the moment?
Somebody.
I'll take it. I will take it. All right. So I can start at a high level product definition, right? What we're building. So, you have this paradigm in sequencing. You're either a short read platform or you're a long read platform. Some of it gives a lot of, fragmented information. A lot of the other, long read technology is expensive. It gives you a lot of information, but it's not very accessible. So the technology that we're developing, and I'll let Lawrence and Dave elaborate further on the details, but the sensor that we're building actually allows us to just have access to DNA. Long read, short read, microarray. So whatever you're interested in looking at, something in sequencing, for example, especially in diagnostics and cancer sequencing, for example, formalin-fixed paraffin-embedded tissues, for example, are highly fragmented and are very difficult to sequence, right? And usually use short read platforms to sequence those, but it's incomplete in terms of information. Our platform could very easily just do all of it, an FFPE sample very easily, and at a very inexpensive price. So I think the way that we're putting this instrument together, not just the sensor, but the optical unit that goes with this is essentially off-the-shelf componentry. We don't need anything very specific for what we're looking at because our signal to noise is so high. And because of that, we can offer a very inexpensive solution that eventually we hope to find itself as a routine platform that could be utilized by GPs or by other healthcare industries. So hopefully that answers, at least on the product spec side, what makes it unique is that this is a technology that allows us to not be in this paradigm of short read or long read. It's any read, right? And I will let maybe Dave, you want to take the specifics around plasmonics? The nano antenna? What makes it interesting?
Well, I mean, I'll just maybe briefly just say the sensor is the magic, and the sensor allows us to do things in ways that we believe will be essentially faster, less in manufacturing. It's going to be very easy to assemble. But from the customer perspective, I think it's really what Marasa has alluded to, which is a great deal more flexibility. So the short read platforms have inherent limitations due to their biophysical characteristics. The existing long read platforms have their limitations. Technologically, we do not suffer from those limitations. So it kind of breaks that dichotomy. There's no reason why not.
Thank you.
RNA is possible.
Long RNAs, short RNAs, targeted payloads.
I think we had someone else raising your hand. Yes, please.
Thank you for sharing. You guys have definitely amazing experience in commercialize the technology and academia to the industry. So some companies, some startup fail and some startup succeed. So I just would like to know your thought about some common mistakes. So the people that made during that they would like to transfer, commercialize their technology or some patent in academia to industry. then we can try to avoid when we are doing our company.
I'll take a first shot. There are probably 6 big categories in there, right? There's management, there is the idea itself, the technology, or what is the product going to be. There is the competition that sort of feeds into that, the feasibility of this technology to move into a commercially successful area, and IP. Do you own what you own, and do you have the freedom to operate in a place where you want to commercialize your product? There's probably a bigger list in there. Financing, money, where is all that going to come from? There are some basic concepts that it took me many years and talking with folks like Brock to sort of match. You'll hear, this is something Marasa and Dave are great at, is matching the product fit, the product definition to the market. Does your product, their MRD, PRD is something you can Google, and there's all sorts of Venn diagrams about, how do you define your product, how do you define your market, and where it overlaps is your strength. There's other kind of crazy terms like SIPOC, what are the inputs, what is the process, what are the outputs that lead to the consumer or the product? And so you learn some of these things just by default because you start to interact. For me, the big lesson was to talk to what would ultimately be the exits for these companies, talking to the strategic companies, trying to figure out what they were looking for, what they would acquire, what they would implement, and it could be a therapeutic, it could be a device, but sort of understanding the strategic space and the strategic white space. And then when a technology like Lawrence has come up, you go, oh my goodness, that hits an area that people aren't hitting. It'll provide a solution that doesn't exist. Then the last part of all of that is, how are you going to fund it? And for me, that's been the roller coaster ride. Because some great ideas I've seen fail because they couldn't attract the funding because they didn't understand what they were going to do. They didn't have the market understanding, or they're building something so esoteric that it was only going to be a cure for a very limited market size, right? And so it doesn't make a venture investable thesis. So as you go out and start to think about these companies, you want to work back from, okay, I'm going to be a $1 billion company, but what's it going to take to get there? And that may be the venture investable thesis versus maybe a smaller company, an angel, something else that sort of spins out at a smaller scale. I don't know if that helped, but...
I'll add a couple things to that, just two. The single biggest reason companies fail is lack of alignment. Everybody has to buy into the same concept. Their passions have to be aligned, their money has to be aligned, their belief in what market you're going after, everything that Bill just described. He can have his, Marasa can have her version of the same thing. Lawrence, Dave, all of us can have it. If you do not have alignment, you fail, period. Doesn't matter how good it is. And then the other simple thing is you got to be able to tell good from bad. It's as simple as that. Is that good data or is that bad data? And that's a lot of intuition, and it's keeping your mind open. But you got to tell good from bad, and you got to know when you've got alignment.
Just a quick comment. So I've been part of a couple companies that have failed, and a couple that have succeeded extraordinarily well. And I would say in both cases where things have gone well and things have not, it's really been about the trade-off between time and money, right? And where you put that, right? So you are essentially, as a startup company, you're fighting something that you completely have no control over, which is the passage of time, right? And so the quicker you can get to a milestone, the quicker you can get to an answer, the quicker you can gain alignment, the quicker you can fix any company culture issues that you have, you are in a better place for that next fundraise, right? So you get money. If you are faced with a decision in the laboratory where I can spend $500 to get a reagent today versus $10 to get the reagent 2 weeks from now, yes, you're saving money, but I'm also losing a lot of time. Right? So for startup companies to be successful, being mindful of that is not just at the bench, but this is overall even at the program level where you're building your product and this multidisciplinary effort. Where am I going to throw money to make things go faster? Am I going to build the team in-house and hire a bunch of engineers and it's going to take me 6 months to get all the learnings and understand how to put the system together? Or am I going to spend $3 million and do a contract engineering and build, hire a team of people who know what they're doing just to accelerate? So this trade-off is very important, and getting alignment on where to make those trade-offs is exceptionally important for the success and failure of a company.
I'd like to add one comment too, because your question resonated with me, and I think a lot of you are more academic in your orientation. Technologists often become so wed with their technology that they just build really cool things, and then they stand back and say, look at this really cool thing that I built. And they don't get to the actual important step, which is who is going to pay me money for this. My own journey at Pacific Biosciences, several years, they sold the branding as this is a single molecule sequencer. The customer base, the base that Brock built, said, we don't care what happens inside the box. Mm-hmm. We want to know how it's going to make our research move faster, to give us more publishable results, generate new biological learnings. Mm-hmm. So the technologist has to be able to translate that technology to what that product looks like, which is why we have this team, which is allowing, forcing us to define that early.
One final question at the back. Just use them.
Thank you. I'm Matt Baker. I used to be a postdoc with Lawrence, and I was really interested in the concept of startups as a better team endeavor than academia. From the other angle, I totally agree, and I think part of this reflects in academia. We have the Lee lab, the Baker lab, the Rodriguez lab. It's not the Lee sequencer, right? But I was going to ask, how can we be better at being team players as academics, and how has working in the startup world improved you in that sense, if that's a overly generous question?
I'll take a first shot at that. I think my world bloomed when I started developing the collaborative effort to validate the technologies I was sort of working on. So like I said, I sort of started building cell sorters and flow cytometers. We really didn't know what cell sorters and flow cytometers were going to lead to when I got started. But cell sorting led into chromosome sorting. It led into everything from infectious disease to immunology. And that collaborative nature opened my world. Suddenly I'm out and talking to people all over the world and creating those key collaborations that lead to these new ideas. It sort of led to the next thing. And so the ability to tell the story, and Lawrence has a wonderful story to tell now, is going to open up all these other worlds in terms of collaborative efforts, which also leads to success of the lab. So with my academic hat on, we can hang our hat on a few things where we've got good collaborations, where we're part of larger efforts, which are multi-institutional. I think that also brings credibility back to the university. So it helps with recruiting of faculty. It helps with bringing in students and postdocs. So not just funding, there's the other intangible pieces to it. And all of us are sort of on this intellectual quest. That's why we do what we do. That's why we are scientists. And so we just learn every day, and the more people you sort of bring into that circle, the more opportunity. So that's my, dumb philosophical answer there.
Lawrence, do you want to add that?
I have a one-liner. Create interdisciplinary projects for each of your students. it forces people to get outside their comfort zone. I mean, my training was very traditional, and I did all the work for my thesis work and my publications. But if you look at what happened in Lawrence's academic lab, the students had to collaborate together to be successful, because one person had a computational piece, one person had a chemistry piece. And the big academic labs in the US function that way. They tackle hugely interdisciplinary problems for which no single person can pull all the threads together.
Lawrence?
I think there's a cultural difference as well, which as an academic you can choose to pay attention to or not, because the academic sense of value says that there's value in being the lead or being the person who is owning this, and I have to have done everything. And there's an artifice in that game. You know, when you go to, I remember when I went for promotion and I said, well, we built this Center of Excellence, we've done this together, and, you know, I was a part of this team. They said, no, you did this. Tell me what you did, or what you led. And that culture can kind of trickle down to the operations on the ground. And I think what would help academia to be more team players is to distinguish between the game, because that part is a game, and what's actually effective at being, achieving something that's worthwhile. So if the culture comes down that I need to be the lead, I need to be the hero, and that game has trickled down to the culture in your lab, then it's everyone's siloed. You know, I'm competing against the guy next to me. I understand that because, you know, we all fear for our job in academia. It's very competitive. I don't have a job in academia, so we're scrambling to get a position. So I think there is a decision to be made when you're running your own academic lab about what type of culture you want to build within that lab.
Rob, some final?
Just a very quick add-on to what Dave was saying. Go take what's become now classic, two very different fields. Experts in those two very different fields, cram them together. Force them to breathe the same air. And they will find connections. That's where invention comes from. Now that's so well ingrained already. These days you kind of have to bring 3 or 4 together. Now the 3-bodied problem is really tough, but that's where the innovation's going to come from. That's where the exploration, that's where the joint effort's going to come on, the codependencies.
That's fantastic. So it's been very quick 1 hour. I have many more questions, but I just wanted to say that I am personally honored to have this panel on stage today. It is phenomenal to hear how the innovation developed at UNSW by brilliant academics actually has the potential to become the driver of a third big revolution and shift in the genomics and how we treat diseases and making healthcare more affordable and accessible for everyone globally. Hence, the title of the session today was really From Genomics Research to Global Impact. And that's why we do what we do. So please join me in a huge round of applause for the panel.